In 1984, India seemed like ahead of this semiconductor chip race. It set up a laboratory called the Semiconductor Laboratory in Chandigarh. 40 years later, we seem to have missed the bus. We are now importing 95% of our chips. What went wrong from this particular thing that we started, which we should have been the leaders, but we are the laggards?
It's very important that we understand the importance of semiconductor industry. You gave the examples of mobile phones, electronic items. Today, semiconductor chips are used in practically everything that uses electricity, whether it is a refrigerator at home, whether it is the television set, whether it is the scooty which uses battery and the engine is controlled by chips, whether it is a small car, big car, whether it is a train, aeroplane, practically everything in our life today has chips which control the electronic circuits. So it's very, very important to understand how this foundational industry works. When I say foundational industry, the word is synonym to the industries like steel industry, chemical industry, plastic industry. There are so many industries where if you have the basic foundation in your country, then you can build upon that foundation and create many other industries. For example, if you have the steel industry, then you can have steel fabrication, you can have manufacturing of machines, you can have construction of bridges, you can have construction of buildings. It's a very, very important industry, right? That is the nature of this industry. This is a very complex industry, significantly more complex than any other manufacturing activity that you would have ever seen. This complexity means that only a very few countries and a very few companies can really get into this.
It's a bit like space and atomic energy, where you have
exactly
an exclusive club that is there.
Very good analogy you have given. It's like space and atomic energy, where the talent required, the skills required, the knowledge required is very deep,
right?
Very deep, and it has to continuously evolve.
Right.
It cannot stay stagnant. It has to continuously evolve.
So, can I come to the primary question that I asked? Because the Prime Minister mentioned this on Independence Day. He said, we set up this chip plant in 1984 and we didn't seem to have...
No, so there is history even behind that, but I don't want to get into political discussion here. Fact is that in 1960s, Fairchild wanted to come and set up a plant here, then Intel wanted to come and set up their plant. It has been from 60 to present time, 60 to 2014, practically it has been a period of missed opportunities, but let's not get into that. What's important is, as our Prime Minister said, now we must be drivers of this bus. We should not be looking at the bus that we have missed. Forget the political setup of those times, that era. What's important is today our Prime Minister has a very clear vision, clear focus, laser sharp focus on execution to make sure that the semiconductor industry gets developed in our country.
Let's turn the question the other way. There were lessons that you have learned from that, those particular experience we had for 40 years. Let us now look at the Indian semiconductor mission that you launched in, I think, 22, January 22, announced in December 2021, if I remember, right? So how different is the approach of this particular mission? Because we did have a mission in 2007 also, that the Modi government initiated. How different is it from what was happened in the past, and what were the lessons you learned and incorporated and made sure it wouldn't happen in this?
What's important is we understand the nature of this industry. This industry works very well when the entire ecosystem gets developed. There are more than 500 chemicals which are used in manufacturing chips, right? There are more than 50 gases, and these are chemicals and gases where you measure purity not in parts per million, but in parts per billion and parts per trillion. These are ultra pure materials. For getting ultra pure materials, for getting that entire stability of the grid, getting that stability of the entire foundation, all those things are extremely important. One has to work very diligently to make sure that the entire ecosystem gets developed and the foundation of this industry gets laid properly so that the industry can have a run for next 20, 30 years, 40 years. And we have to look at the entire value chain. The value chain starts with design, comes to fabrication, Then comes ATMP, which is assembly, testing, marking and packaging. Then comes the modules. The modules go into the finished product. If you look at the value chain, this value chain is supported by next layer of all the chemicals and gases. Then the value chain is supported by a series of EDA tools, other consumables, all other items which go into this. The equipment which goes into manufacturing. Then comes the ultra pure materials which are used for manufacturing chips. So this is the complete ecosystem that needs to be built. You can't build just with a fab or setting up one unit. You have to look at the entire thing.
So how did the semiconductor mission that you've launched actually take care of all these processes, the ecosystem that you talk about?
We have worked diligently with every ecosystem player. Very, very diligently we have worked with chemical gases, with the equipment manufacturers, with the consumables, with the material suppliers, material manufacturers, with the state governments, with the local level panchayat and municipal governments. We have really, really worked very diligently with the industry to come up to this stage today. And
when you say this stage, what is the stage we are at today in this journey? It's now 3 years since you launched it. What is the stage?
This is an industry which requires a minimum of 10 years to get established.
Right.
That's the experience everywhere in the world. China took, I think, about 20 plus years. Japan began way back after the Second World War, and US it started somewhere during the Second World War and immediately after that. So this really, really takes some significant time and effort to build up. So today we are at a stage where 10 units are under construction or under planning. The first unit which has started pilot production, and we have the pilot production chips in this entire thing. You can see the pilot line chip. This is CG semi line, which is the pilot line. Kane's pilot production will start very soon in next few days.
First one is from Micro.
This is from CG Semi.
Yeah.
This is from Kane's, and this is from Micron. Again, they are going to start the production in around December.
So in that value chain that you talked of, the ecosystem, these companies fit in where in it? You started with the fact that you have to do the fab and the ground level. Where do you set up industries
in this value chain? Design, we all know that we have a very good strength.
Which is indigenous.
Yes, our people, a lot of companies working here.
The GCCs.
And recently we inaugurated one facility of ARM, which will be designing the most advanced 2 nanometer chips.
Wow, which is like the cutting edge.
The cutting edge, right? So that's really, really satisfying that. And again, the entire end-to-end design is going to happen.
So that's one big component.
Then many startups are already supported under the design linked incentive that we have. They are coming up to speed. They are getting VC funding. Their products are getting validated. So the design piece is in good shape. Fab, we have selected one fab, Tata Fab, which will be set up in Dholera. Construction is going on at very good pace. ATMP, we got 8 units. We have 2 fabs and 8 ATMP units.
That is the testing.
Assembly testing, and assembly is again a very, very complex thing. If you look at, this is the wafer, right? A raw wafer would look something like this. And this is of course the substrate.
Silicon base, right?
Yeah. Inside is silicon, then there is a cover of other materials which give the strength to the wafer. This is, now once the wafer is, raw wafer is put into the fab, this has to be fabricated. Fabricated means you have to draw the circuit on the wafer. Imagine if you, let's take this leaf. Let's take this leaf, right? This is a small leaf, small piece of a leaf. What can you write on this? You can write Raj Chengappa on it.
No, not even that.
Now I ask you to write the entire India Today on this. Entire India Today. Your one full copy of it, right? Then I ask you to write 10,000 copies of India Today ever since it began on it. 50 years ago. Then I ask you to write all the magazines which are published in India on this small piece of leaf, right? That's the fineness with which we have to work. So that is what nanometers is, right?
To say a nanometer is 1 billionth of a meter, right? That's the unit that we're looking at. So it's even thinner than your hair.
Significantly thinner, 10,000 times thinner.
Right.
Hair is 10,000 times thicker than a nanometer.
And on this, you will embed millions of transistors and circuits that are there.
That has to be embedded on this.
Got it. So this is the what you
This
call
is
the
fabrication.
Fabrication.
Now,
Yeah.
once you fabricate on this, you have to take out that small little thing which not even visible to naked eye. It has to be seen through very, very sophisticated equipment.
Right.
Not even a simple microscope will be able to show you. Right. That has to be taken out and given a body.
Right.
So that body has to be given, and like for example, I'll use this very small thing.
Yeah.
This is now a body which is given to a very small little chip inside.
Correct. Almost like a SIM card size.
Yes, but there's a very complex ecosystem built in this now.
Right.
There is a plumbing system,
Right.
there is an electrical system. Many of the chips would be so complex. For example, this chip that you see here,
Right.
this chip that you see here has multiple stories inside, multiple floors like a building complex.
10
It is
story,
a
20
10
story
story, 20 story, 30 story kind of thing.
This is called the GPUs, or this is the...
This is a microprocessor, this is a controller. So there has to be a plumbing between those stories.
Right.
There has to be a lift which has to take things from up and down. There has to be service lift, passenger lift. There has to be electrical connections. There has to be some people living in top floor having different way of working. Some people living in middle floor, different way of living. So it's very, very, very. Yeah, it's many cities.
City, that's right. So you've got 8 companies that
That
are
is
doing
the process of ATMP.
ATMP, right?
Taking that small little tiny
and
thing
then-
and giving it this.
Right, and
entire
then you
body.
have the packaging.
Then the module. This is a module.
Okay, that is the packaging.
No, packaging is making this body.
Okay, that, and then you.
So this is as complex as fabrication, not
Right.
exactly as complex, but a couple of orders different, but very, very complex.
Excellent.
Very, very complex.
So you have now set up.
So 8 units of this,
Right.
2 units of fab.
So you have covered the spectrum of the universe or ecosystem as you
Then
see.
comes the module making.
I see.
Module making is in electronics.
Right.
That is where the
Right.
electronics manufacturing comes in.
This is what gets into your laptop or whatever it is.
Correct. This then finally goes into the finished product.
So if you take a look at what the government's policy was to invite these big companies to do it, what are the kind of incentives you all gave, and compared to other industries, why did you all do this?
See, the global benchmark, if you look at what our countries which are of our size have done, they have poured in billions and billions of dollars in this entire industry, because this is a strategic industry. This industry requires support through the vicious cycles which
That's true.
come in. And the way the industry is growing, and the way as I said right at the beginning,
Right.
the nature of this industry is today of a foundational industry.
Right.
So being a foundational industry, it has to be supported by government, and across the world that is the practice, and we also followed the best practices of the world.
So what were the incentives you all offered companies?
We have offered incentives which are in line with the semiconductor mission policy, which is supporting the capital expenditure as well as supporting the...
That's 50% of the investments government
Yeah,
India
of the eligible investment is
and
there.
25% the state
Some state governments have supported.
will chip in. That's the basic thing. Totally, how much has come in the last 3 years since we set up this thing?
We have the numbers.
I think it's $18 billion.
Yeah, it's about 18, 19 billion dollars.
Right. So that has come in now. And are you planning to do more, set up more such units, or what is the process?
The world today trusts India.
Right.
The way our foreign policy has been conducted over the last 11 years,
Right.
the way we have come up as a very trusted country,
Right.
trusted partner, the world trusts us. That's why every ecosystem partner,
And you'll take
the
route from
equipment manufacturers, they are coming to India.
Right.
They have already set up their bases here.
Right.
They are also going a level deeper now. For example, a few days back I was in Bangalore, and we saw some of the components which go into equipment manufacturing.
Right.
So equipment manufacturing has also started. So look at this. We are going to manufacture chips.
Right.
We are going to manufacture the machines which make chips.
Right.
We are going to manufacture the materials which make chips.
Right.
That's the whole ecosystem we are working on.
I have a lot of things that happen in, say, aviation. making our fighter jets. We imported those parts, we got them what they call semi-knocked down or completely knocked down kits and assembled them here. How much of know-how and know-what is being supplied by these international companies when they set up these? Or is it just they will make and we don't understand the technology?
No, it's not that. I was, in fact, yesterday this last visit to Bengaluru, when I was discussing with the team which manufactures the components,
right.
I was very pleasantly surprised that the main manufacturer of the capital equipment,
right.
they basically gave them the design specs.
Okay.
Not a print to manufacture.
Right, not a blue, and you just have
No. They gave the specs, design specs, and this team designed the entire components,
right.
the series of components, and then supplied. And the feedback is that the components designed are significantly better than the components which are currently used in the print to manufacture.
Even in these 10 companies that India has invested in and jointly developing it, they have agreed to transfer the technology to their partners that are here, and therefore...
And some of the technologies we have already developed ourselves.
Right.
In a research unit in Vemgal,
right.
Tatas have already they have developed the technology for the ATMP.
So there is a tech transfer part. So that
tech
is
transfer,
own
development.
Now, when can we expect the first made in India chip to come out?
This year already.
Yes.
This is our first made in India chips, this entire set, and these are the student chips.
Correct. Yeah, I'm saying commercially.
This is a commercial chip from the pilot line.
From the pilot line. Yeah. So it's already out, you're saying, a made in India chip.
Correct.
The Prime Minister unveiled a made in India chip called Vikram, which is the 30
that is from the SCL Mohali.
Right. The only thing, and which was done with a lot of fanfare, of course, an achievement, but given the fact that your own computer has a 64-bit chip and this is a 32-bit chip, why do we think that this is a significant development when actually these processors have gone far more sophisticated than what this particular chip does?
We should have had a leadership like Modi ji's leadership 60 years back, right?
Right.
Then we would have not lost those so many decades that we lost.
Right.
We would have gone ahead significantly earlier.
Right.
But now we are definitely on track to achieve some of the best devices.
Okay. So if you take a look at our design strength that you talked about, how much of that can we leverage into this? We, I think, constitute almost 60% of
20% of the global design capability.
20% itself, okay. And so how much of that can be now utilized and brought into this huge semiconductor industry?
It is playing out very nicely because there is a natural flow from design to manufacturing.
Right.
The example that I gave you of the components, because of the design strength, the global equipment manufacturers, they are giving the design specs. They are saying that, okay, I want something which will withstand this much pressure, withstand this kind of temperature. This is the plasma environment in which it has to function, and this is the precision with which. And then we come out with the product itself.
Okay.
So our design capability is our biggest strength. We must build upon the design capability in a very significant way.
Now you have these big chip makers like TSMC, NVIDIA, and the Chinese, of course. Will any of these collaborate with us, or are in talks with them?
One of the big ones, PSMC, has collaborated with Tatas, and Micron is among the top 5 in the world, so they are also here.
Now looking at Taiwan and bringing their
PSMC is from Taiwan.
From there, but the big guys, no.
They will also come. Obviously, they will all come. When the journey begins,
right.
See, it's very important to understand when you start a totally new industry.
Right.
The world will always look at you with a question mark.
Correct. Yes.
So those question marks are now behind us. In this semicon, ASML joined us.
Right.
When ASML joined in a large contingent, and
you'll have to describe ASML to us.
ASML is the most complex equipment manufacturer without which no chip can be built.
Right.
It's from Netherlands. It's a company which is today among the most strategic companies in the entire world.
Right.
Between TSMC and ASML, the world cannot function without these two companies. That's the importance of these two companies. ASML came in full contingent, their entire top leadership was present here, and they very categorically said that we now believe that India is absolutely on the right track to become a semiconductor nation.
It's a good time to ask you the question is, We are now importing close to 95% of our chips. How do you see in the next 5-10 years we start now making them indigenously and not cut down on our exports?
Very good question.
Yeah.
If you look at the way we have selected our 10 projects, right? All the 10 projects, if you look at it, we have practically covered every sector.
Mm-hmm.
I'll talk about some of the sectors. Memory, which goes into practically everything. Power electronics, which is very crucial to your electric vehicle industry, trains, your large machines, industrial electronics, all that. Then comes the consumer electronics. The display module, which drives every TV and every display, that is part of our program.
Mm-hmm.
Silicon carbide, which is a material for the future, that's part of our program. RF, telecom, which are used in radio, radar, all that thing, that is part of our program. So we have practically covered every segment, all the medical electronics which is required, that's also part of the program. So we are practically very methodic, and the entire semiconductor mission is run by professionals.
That's true.
It's run by professionals.
No more
No, it's not
government or public sector. That
we have some of the topmost brains working on it,
and
people like Vinod Dham, who's father of Pentium.
And that's the difference you brought in, I would gather, in this mission that is
correct. The mission is run by professionals,
right.
And they are the ones who are guiding us in this entire thing. So we are able to today cover practically every segment. So as these facilities start coming online, we will have a significant part of our domestic demand met. But we must also understand that semiconductor is a global industry.
Right.
It's an industry which is absolutely global. It doesn't know the barriers of country's boundary, and it has to, each material, each component has to pass through multiple boundaries every time it becomes a finished.
And I think that's a very good point, because COVID showed us how, and I quickly want to do two areas. One is, of course, the whole business of AI, which is now coming in. You have a artificial intelligence mission. How does this dovetail into that? Because in AI you need giant processors, GPUs,
absolutely, the chips,
and,
high
LLMs.
bandwidth, the high bandwidth memory chips which will be manufactured by Micron, the processors which are getting developed at IIT and CDAC, all those play into the entire AI journey. And I think the way we have consolidated all our forces and properly used the strengths that we have, both the public sector strengths and the private sector strengths, I think that's going to be a good journey.
Would we be a player? Because so far we have not been a big player where AI is coming. You have ChatGPT, you've got all the big companies doing it. Where do you see our entry?
See, the world of AI models is evolving.
Right.
If you talk to the experts, they will say that yes, there will be a few very large models, but the big value will come from very small focused models which are focused on solving a problem. For example, yesterday we empaneled 8 new model makers, where one of them is focused on material science.
Right.
Another one is focused on weather forecasting. Another one is focused on agriculture.
So you're doing the niche things.
Each of these niche will be very important for us, because then we can solve some of the population scale problems using these technologies.
India has a agreement with US on critical and emerging technologies signed by the previous administration. Do you see the current administration encourage us?
Absolutely, it's going on very well.
And finally, this is the last question I have, is in terms of what we're doing in semiconductor technology, would this be, and that's why the previous question I asked you, would we now be able to drive a lot of jobs into this, and what is the potential on that front?
See, we started this program of talent development. We took like in telecom, we had 5G labs set up in 100 universities.
Right.
So that the students basically get the right, absolutely hands-on experience of the technology. Mm-hmm. Similarly, in semiconductors, we have given the latest design tools to 278 universities.
Oh, wow.
And these are latest tools from Cadence, Synopsys, Siemens, some of the most latest tools which are actually used in the industry, the IP cores which are used in the industry.
Right.
And the result is very short time frame of 2.5 years. Students have designed chips based on the design tools that they have access to, and we have used the Semiconductor Limited Mohali to tape out these chips, to manufacture this chip, fabricate these chips. Now, if you are a startup, right, and you design, you have a great concept, you get the design tools and then you design a chip.
Right.
Until and unless you give a very large order, no manufacturer in Taiwan, South Korea will ever even touch your chip. So we have created a concept by which even if somebody wants to manufacture 10 chips,
Right.
we are using the semiconductor laboratory as a platform for giving that opportunity
Excellent.
and we are modernizing Semiconductor Limited SCL Mohali
Right.
to increase the production, modernize the technology and simultaneously use it as a research base for our students. Very few countries in the world can today claim that their students, university and college students, can design and tape out chips.
So this is going to be a huge driver of jobs. You think?
Absolutely. That much in emphasis we have given to talent.
So you're building
development.
the knowledge, know-how, and the design capability. Final is, how would you say 5 years from now or 10 years from now, what will India's semiconductor industry look like? What is the vision you have?
It will be a very comprehensive industry. 5 years down the line, we would be manufacturing chips, we would be having a lot of R&D, we would be having great equipment manufacturing ecosystem. We would be having some of the most complex and most required new materials like silicon carbide being manufactured, the material itself being manufactured in India, gallium nitride being manufactured in India. The chemical guys are already setting up their base. They are looking at India as a research and development and manufacturing base. So it's a journey which will become a very significant industry in the coming years.
How would you characterize it? Would you say it become the hub? Would it be cutting edge?
It will be a comprehensive industry. See, starting at 28 nanometers was a very, very important decision we took.
Right.
And now we have once we learn how to make 28 nanometers, then we must move towards the other leading
28 just to explain to our viewers, listeners, 28 nanometers is the fundamental basic thing that drives much of what we do.
Close to 60% of the semiconductor market is about 28 nanometers and above.
Right, okay.
So it's a very important, 28 nanometer goes into all your refrigerators, TV, everything practically, every consumer electronics that we use. So it's very, very important 28 nanometer and above.
So we'll be self-sufficient in that particular aspect?
That chip we start, then we move
to cutting edge
towards 7 nanometers.
Wow.
And it's a complex journey. It will require lots and lots of efforts. It's not like any other manufacturing activity, as I explained, the complexity of it.
Thank you very much
Thank
for
you.
the time you've taken.
Thank you, Raj.
Thank you.